Good morning. Thank you. So I'm Todd Hollmann. I'm from the Data Center Network Engineering team here at Facebook. I have been, relatively short timer. I've come up to speed on most of this, and we'll give you our history. So before I get too far, how many of you went to the original networkers before it was Cisco Live? Okay. Did any of you take a Catalyst troubleshooting class? Okay, good, I'm safe. I taught that too many times, and I'm gonna make sure I don't have expectations to deal with in the crowd. Thank you. So with this, most of you know Facebook's direction inside the data center is Fabric. We have posted this, all this available information on the Fabric is available on code.facebook.com. I encourage you to go out and look at it. Fabric is IPv6 goodness. So we've designed it from the beginning to be IPv6. And honestly, we designed it from the beginning to be IPv6 only. So all of our fabrics only have global IPv6 space. There is no global IPv4 anywhere in Fabric. So day one, Fabric, goodness. But where did we start? In the beginning, we had layer 2 clusters. I know some of you are there today, big layer 2 networks, how to work it. For us, a cluster is basically a group of servers that deploy at a similar time and are given a specific function. So we deployed clusters. Yay. Clusters in the old day, we had 2 cluster switches. We had a large number of top-of-rack switches. Each top-of-rack switch had a single VLAN, all layer 2, up into the cluster switch. Cluster switch did all of the routing. So we had thousands of hosts per cluster, which is great. It scaled, well, kind of, sort of. Every device had 2 IP addresses, one for production, one for out of band. That's great. But with all of this, we started running into ARP issues. We started running into DHCP issues. We started running, just scale of hosts being routed was huge. So how do you do v6 in that? Well, honestly, you don't. You were already running into ARP issues. If we turn on v6 with 2 IPv6 entities on every server, it's actually at minimum of 4 neighbors that we have to add. We're already having a problem with ARP. Adding v6 neighbors into this environment would have melted our gear. It would have been horrendous. So how do we get to v6 in a big layer 2 cluster? Well, the answer is, and Will already kind of alluded to this, we add v6 to the cluster switches. We add v6 into the load balancers. We advertise v6 VIPs, and we proxy it into v4 for the rest of the cluster. It got us working. And it got us through World IPv6 Day. But the key to this is Backbone did the vast majority of the work. Adding v6 to a cluster switch, adding v6 to the load balancer, and bringing up VIPs, amazingly simple compared to what Backbone had to go through to make it work the rest of the way. So we didn't have to do all that work day one. But it made us think, what was the next step? We knew we couldn't do it layer 2. How did we go about it? Well, at this point in time, early 2011, we were trying to figure out what the next generation was. And for us, that next generation was a somewhat iterative step. L3BGP. So we still had the same /24 per rack switch, but instead of L2 up, we now had L3BGP uplinks. From a resiliency standpoint, we got rid of just 2 cluster switches, and we now had 4 cluster switches. So it's a 4-post network. Trying to move to a 4-post, 75% utilization of the network, drive toward 4, a lot more better utilization of the cluster as a whole. How many people have ever said this? Yes. A lot of people have said that. I've said it multiple times in previous jobs. We'll never run out. We can't run out. Well, guess what? We got there. Will also alluded to this before, but I want to put a slightly different twist on it. Okay? We did not get to running out of IPv4 space because we did stupid stuff. We did it for the right reasons. We looked at a cluster and said our biggest cluster is going to be a /15. So it makes sense to put every cluster as a /15. Stamp it out, right? Simple. The problem is not every cluster was that large. So we ended up wasting an awful lot of IP space on clusters that, were a quarter or a third or whatever the size, and there's no way to really reclaim it without re-IPing. It made tooling easier. We had wonderful route summarization. So we kind of got there for the right reasons, but we got there incorrectly. So how do you solve this? Re-IP, as Will also alluded to, was not an option that people looked at. And it's a short-term solution. You could re-IP. You could do a lot of work, re-IP a whole bunch of servers, and it would regain you some portion of your IP space, which you would then run out of in a year. Okay, that doesn't sound like a good risk-rewards scenario to me. You could request more IP space. Yeah, same problem. They're not going to give you any block that's big enough to do anything truly beneficial with or give you any real longevity in your network. So what was the other option? Well, IPv6. We were going to end up doing a lot of work anyway in anything we did. We were going to have to fix tooling because tooling assumed IP space. We were going to have to fix tooling because, everything was being redone. If we're going to go through all that pain and suffering of fixing tooling, let's take a step forward, not step sideways. So v6 really was the answer. In thinking through the process of IPv6 and how to make it work on our network, this was one of the big mantras that we used. Operations first, features second. So the whole goal was to get v6 out there on the network, usable, maintainable, supportable, and then worry about how do we improve the v6 experience, or how do we add, v6 gives a whole new area of what you can do. But that was not our first goal. And in true Facebook fashion, done is better than perfect. So we needed to get something out there. We needed to start pushing the envelope, getting stuff in use so that we can refine and improve over time. So how did we do it? I could make it sound simple. It's not as simple as we hoped, but it was there. So the key to this is model IPv6 like IPv4 where it makes sense. So we already had BGP-v4 running throughout in our environment. Great. Can we add BGP-v6 over the entire environment? Well, yes, we can. So does that still have the same routing effect? Yes, it does. But once again, you have to think of v4 and v6. They are two separate protocols. Okay? There will be slight differences. So if you're running something other than BGP on your backbone, you're going to have other considerations to take into account. Lucky for us, it was all BGP v4. BGP v6 runs nearly identically, so it's easy to scale and easy to deal with. We had /24 out in every rack switch. Simple solution, add a /64. Right? Route it up. Summarization should work relatively the same. How we do routing policy, all very, very similar. But through this process, we also saw things that we could change and fix. One of the things that really came out is we were already playing with our tool set. We already had the issue where every cluster was a /15. We didn't want to repeat that with v6. So what did we do? So instead of having all of our tooling based on here's the subnet for this cluster, the subnet is now a list of IP blocks. So we can start with a small IP block. If the cluster grows, fine, add another IP block. Our tools understand it, our tools deal with it, our tools now work with it. Okay? Very, very simple change, kind of, sort of, and it affects the whole tooling base, but we were already touching the whole tooling base to move to v6. So it added a lot of scalability and flexibility for us to work on. Somewhat noticeable, do we really need a /64 in every host network? I mean, that is an awful lot of IP addresses. An awful lot of IP addresses. And yes, I did a lot of research and found out a /64 is 3 IP addresses for every square foot of Earth's surface. It seems a little overkill to stick it in a rack with 48 servers. But that's the way it works. We actually looked at other things. So we had no plan for Slack. So we really didn't need to stick with a /64 in our thought process. And a 96 seemed really interesting. Why? Well, it's the whole original IPv4 space in a subnet. Okay? We would never blow through that number of IP spaces in a rack, right? Well, the problem is we were going through this, we found a couple issues. Number one, all of the switching platforms that were out there at the time assumed that you're going to use a /64. So as soon as you went to a /65 or 66 or any other mask larger than 64, you started going into no man's land of routing. And it was treated different. It went into a different table, and you just did not have the scalability you needed in the routing platform to make that happen. So route scalability issues beyond /64. The other thing we found out just in time was the fact that if you used a /65 through 127 and you were in this special table, that special table only allowed you to have one next hop for that route. Well, I've already said that our cluster was 4-post, which means that if you went into any cluster switch, the cluster switch might have multiple links down to any destination, but I shouldn't say that. If you're in a rack switch going out to another rack switch in the cluster, you have multiple paths. But if you only have one next hop, you're only going to use one hop or one path until such time as that link were to fail. I have 4 links out of a rack switch. Do I only really want to use one? No, I don't. I want to spread it as much as possible. So ECMP was certainly something to look into. In the end, we chose to go with /64s for our host network. And honestly, today, what we are looking at is actually going even a step further and start putting /64s per server. There are multiple reasons to look at that and do that, but that is the direction that we're taking. So I know, mind-boggling number of IP addresses that we're going to end up in a single rack because we'll have the network and plus every server having a /64. So we saw the IPv4 cluster before. How did we do v6? Well, our original plan was to have, like I said, IPv4 BGP, or I should say BGP v4, BGP v6. And up to the data center routers, we actually did that. And initially, we did it down to the rack switches as well, until we got to our first big cluster. And we got to our first big cluster, adding v6 onto it, 400 plus racks in the cluster. We had uplinks, we had load balancers. All of a sudden, we had 2 sessions, 2 BGP sessions per rack switch. We blew through this wonderful 1,000 BGP session limit. And hell kind of broke loose. So with that being said, we dropped back, and what can we do? Well, the answer was BGP multi-protocol. So we went back to a pure IPv4 transport, added v4 and v6 within it. Tooling came to our rescue. Everything that we had, all of our smaller clusters before that we had deployed, we went back and rebuilt using BGP, multi-protocol BGP. And all clusters moving forward were built day one with multi-protocol BGP. So that's the good story. That got us to dual stack, which was good. But that didn't solve our IPv4 exhaustion. So every cluster up until this point, we were installing as dual stack. So it had full routable IPv4, had full routable IPv6. We didn't have any more IP space, v4 space, to use for this purpose. So Our final generation cluster design, IPv6 only. And I have it in quotes for a reason, and we'll get into that. So William referred to RFC 5549. We looked at it as well for within the data center. Unfortunately, most of the vendors had little or no support for it. So we had no choice but to stick with multi-protocol, v4. We couldn't do dual session yet, stuck with v4. But how do we do this? Well, we removed global space. Every cluster, the first RSW in every cluster has the exact same IP address on every cluster. We took a chunk of 10net and said we are going to reuse the same 10net space in every cluster. So we plop it out, we reuse it every single time. That 10net space does not route out of the cluster. It is local only. And we run our BGP over it. We have connectivity across it, and it works. The interesting thing was, this took me by surprise when I got here. Our host networks that we use for v4 on the rock switches is actually the 169.254 network. It's not really reserved space, whatever, but we know it's not going to route anywhere. We know it's local. And we do BGP across it from rack switch down into the actual server. So it's there. We used it. The only routable global IP space in a v6 only cluster is v6. So if you want to get into this cluster from anywhere other than the cluster within the cluster itself, you will be using IPv6. So some notes on IPv6 only clusters. Having the IPv4 transport in there has been advantageous. Why? We can still inject IPv4 VIPs into the network. They still get transported across the network just fine. So our load balancers have moved into the server clusters. And with that, we can now inject v4 VIPs anywhere within a cluster. They still go out. They still get transported out. They can still get summarized at the cluster switch and sent out. But all the real server IP addresses that we use are all going to be v6. So we can inject VIPs as v4, but the rest of the network is still v6 only from a routing perspective. Some notes about IPv6 management. So we no longer have the ability from a server over here to talk into this cluster on IPv4. So all of our tooling had to be v6. All of it. It's not as simple as, well, maybe some of you know, it's not as simple as it seems. Trace route breaks, ping breaks. All of your tooling is assuming v4. It is assuming that you have connectivity. So moving all of your tooling from v4 to v6 is a challenge. Most of what we did from management perspective was kind of after we had it dual stacked. And it was playing catch up. And it took a lot more time than we anticipated. So it actually had an impact on how fast we can move to an IPv6 only cluster. So my note there is, if you're heading in this direction, start moving the management sooner rather than later, because that will be something that you are going to run into problems with. I've known of issues where SNMPv6 will not give you any statistics for SNM or for IPv4 at all. Yes. You smile at that, but yes, the MIBs are not fully, you'd think they would be, but no, the MIBs are not fully like interchangeable. So interesting issues, head there. And this brings us full circle back to Fabric. So when we built Fabric, we felt very, very comfortable with our general BGP, or I should say IPv6 setup. So what did we tweak? We made relatively minor tweaks. We went back to dual session. We wanted dual session. We like dual session. We like having the difference between BGP v4 and BGP v6 from a troubleshooting perspective. It's two different planes. It's two different protocols. Yay. Clean. Wonderful. And now in Fabric, we don't have to worry about the number of BGP sessions. We have significantly fewer neighbors on a per device basis. it scales, it works, so we moved back to separate BGP v4 and v6. The only other thing we really added was BFD for both v4 and v6. That was the main, we'd done all the work. We had proven all the work on the cluster. When we moved to Fabric, we had goodness. So, with that being said, inside the data center, we have made it. Whether we're deploying a new cluster, which very few get deployed today, or deploying a new Fabric, it is v6 only. We have no global 10-net space or global v4 space that's put into these environments. We have a VIP subnet, maybe, but that's about it. Okay? We are v6 only inside the data center. We have some stuff, and that was alluded to by the first speaker in Comcast. There are things that are adverse to IPv6. We have old console servers that have been around forever that don't do v6. We have facilities devices, which even when they're released today, don't have v6. So we have ideas and thoughts and ways, and our goal is to get it all to v6. We don't want the v4 around. So console servers, there's plenty of console servers out there today that can do v6 and do it well. It's unfortunately an investment and a change, but at the same time, if you roll it in with other things you want to change, it makes sense. So what is v4 only, which is a few devices we are driving to solve and get rid of. So what do I want to tell you? We did it. You can do it. I am not going to promise that it's going to be a smooth, easy, uneventful transition. But you can do dual stack. You can go from single stack to dual stack. You can then move on to v6 only. It can be done. Key thing to remember, so a feature that works in IPv4, no matter what the vendor says, it might not work in v6. So, with that being said, test. If you need to do 8-way ECMP, it might be working beautifully for you in IPv4. There's a very real chance that it's not going to work as 8-way ECMP in v6. So don't test it as 4-way because that's all I have in my lab or that's whatever. If you need it 8-way, test it as 8-way. If you need 16, test it as 16. Different scale inside of hardware makes these changes difficult or troublesome for some vendors. So that's a problem. And last but not least, start now. If you don't start now, you're never going to get there, ever. No matter what you think, no matter what you hope, there is no single other entity in this room that's going to use all the exact same features you do. I can promise you some of the things that Facebook uses are fixed for you now. But I know you guys use other features that I don't. So until you start deploying it and start using it, you're not going to know what's broken, and you're not going to know what needs to be fixed. It's as simple as that. And that's it. So any questions?
Thanks for the talk. So while running both Office of our single BGP session, what was your feeling about enhanced error handling in BGP? Did you see any fade sharing between v4 and v6?
Okay, sorry, I didn't fully understand the question.
So every vendor claims to have implemented enhanced error handling. You were running both Office over the same BGP session. Mm-hmm. Did you see, I don't know, errors in v4 affecting v6 and other way around?
So with multi-protocol, Yes, we saw some of that crossover. We had some initial issues with multi-protocol, which is the reason why it originally drove us to separate it. And that in that separation, it bought us enough time that most of the vendors were able to fix the issues before we had to recollapse it back into multi-protocol BGP. So we got lucky, right? Timing worked out in our favor, but that's the way it happened.
Hello.
Yes.
Interesting presentation. Thank you very much. Tom Coffeen with Infoblox. I had a question about the basic address schema that you're using in IPv6, and I'm curious as to how much actual address scheme contour there is within the data center, or if it's all just pretty flat from an address scheme standpoint, and whether you're just throwing a single-sized block at all of your data centers, and if so, if that block is, like /48, or is it bigger than that, or is it smaller than that? I'd really like to hear more about that if you can reveal any of that information.
We are indeed doing consistent for data center. Each one of our regions is multiple data centers now, but we do a very consistent block for each data center. Just to help with summarization purposes. I'm going to rely on somebody. Diego, what's our standard block for a data center now?
So we're using a 56 per data center.
Okay.
Thank you. So we have, now that we're building mostly on fabrics, we have summarization per pod, summarization per plane, and per fabric. So we still follow the cluster IP addressing because as on the services side, we still need to use that idea. So we address the fabrics based on cluster addressing. And that's a 56, and then we have a sub-addressing inside the pod and inside the rack.
So simple answer is /56 per data center.
Excellent, thank you.
Yep.
I'm guessing that 56 per data center is going to change with 64 per host.
Yes, it will. But at the same time, the devices that we use are all going to remain still in that /56. The /64 per server is actually going to be coming out a totally different IP block. That's because we're now doing it from a services perspective. By putting the /64 on a server, we now have services associated with the block rather than networking gear. So we're totally segregating the services from the network from an IP perspective.
I presume you'll still want to be able to summarize those blocks too.
Question is we'll be planning to summarize even the secondary blocks. Yes, we will be summarizing those as well. I'm not sure if we've come up with the per region block size, but it is bigger than a /56, I'm pretty sure. So.
Quick question. So why Facebook is using so many BGP sessions even to the server level? So is that layer 2 not good enough for handling the traffic in the layer 2?
Okay, sorry, repeat the question.
The question is why the BGP is used even to the server level, like down to like a rack switch to the server level. That's my question. Yeah.
So why do we use BGP from the rack switch to the server? Simple answer is we want to allow the server to inject. So we do a lot of our traffic management with internal tooling now. So with that, we can now inject IP addresses from wherever they need to come from. And if we move a service, the IP address can move with the service across the network. And we need the server to be able to control that. We don't want the network to control where a specific IP address is in the environment. Yep. And when we start looking at V6 or a /64 per server, that is also going to be advertised from the server into the rack switch with BGP.
You had mentioned that you're still using V4 VIPs. Can you talk about if there's any of the services in the cluster where you're actually providing V4 to V6 services, or once something comes in to reach a V4 VIP, does it remain a V4 service within the cluster?
I'm probably not the best person to answer that. From a network perspective, it is my understanding that the V4 VIPs are out there to provide backward compatibility. So what comes as V4 responds as V4. Obviously, everything in our power is to try and move everything to V6. So anything that has a V4 VIP is always going to have a V6 VIP as well.
I can answer the V4 thing. So the V4 and the V6 only clusters are mainly for origin fills from our CDN partners, and we've actually been actively pushing them to do V6 fills. So it was just kind of a backward compatibility thing. Most of our traffic hits our edge, which is where the majority of our V4 traffic lives. But also just like internally, we do not have V4 services. So this is only internet-facing V4. I think we can do just one more, and then.
Just a question about security filtering, ACL, firewalls. Were there challenges in migrating that, or has that been done?
We as a data center networking team, we do not have any security filters. So our security filters are taken care of by the edge. So most of the traffic that actually comes into the data center all originates at the edge already. So unfortunately, that would be a great question to ask Will. So if you find him, you can ask him what they ran into from that perspective. We have a few places that actually still do use filters, but it's relatively simple and easy to do, so we don't have any significantly complex IPv6 filtering inside the data center.